If the resistor is the most used component in electronics, capacitor definitely takes the second place. In this video we will analyze how does it work without ever neglecting the practical aspect that will help us understand why they are so important. So we can start analyzing the capacitor as an abstract concept. The definition tells us that it's a component able to store electrical energy in an electric field. But what does it mean? So is it a battery? Well, ideally we could see them as a battery when the capacitor is charged, but obviously in reality it behaves differently. Let's see the differences between these two components that can often be confused. The first difference is that the battery is an active component, while the capacitor is a passive one. What does it mean? Simple. The active component delivers power or energy to the circuit. Instead, the passive component utilizes power or energy in the circuit. Furthermore, the capacitor stores potential energy as an electric field, while the battery instead stores energy as a chemical energy. This is not all. In fact, the energy release time is also different. Under the same conditions, for example turning on a LED, the discharge duration of a battery is much longer in time than the capacitor, which is almost instantaneous. In fact, with huge capacitor we could reach a duration of about 10 seconds, while with battery it takes several hours. It is also possible to calculate precisely the charge and discharge of a capacitor compared to a battery, but this will be the subject of a dedicated video. Let's see what happens if we charge and connect a capacitor and a LED to a power source. As we can see, the LED emits a fast flash and then goes off. In order to understand this, we need to have a look to the behavior of the capacitor. In the simplest case, we can consider a parallel plates capacitor. In detail, the two plates originally are neutral, but when we apply a voltage, charge starts to flow. For convention, we are assuming that the flow of charge starts from the positive pole to the negative one, but in reality is the opposite. So, due to the applied voltage, electrons start to move according to the current. In particular, electrons will accumulate until the left plate will have a net positive charge, and the right plate has so many electrons that it's impossible to push other electrons in that plate. So, at the end of this process, one plate is charged positively and the other one negatively, and the current can't flow anymore. For this reason, the LED turns off. So, how can we measure the magnitude of a capacitor? The value of a capacitor is also called capacitance, and it is expressed through the formula C equals Q over V. In the formula we have Q, which is the electric charge, and V, which represents the potential difference between the two plates. For now, it's enough to know that for a parallel plates capacitor, it is possible to calculate the capacitance through this formula, where epsilon 0 is the absolute permittivity, or generally the permittivity of air, that is equal to 1. Epsilon r is the permittivity of the electric, and d the distance between the two plates. What you usually do is to use a dielectric material between them to increase capacitance. As we said, we can make a capacitor with different shapes, like a sphere, but the calculation starts to be a little bit difficult. So, for the moment it's not necessary to go in depth. It's also possible to make a DIY capacitor. If you're interested to learn how to make it with some paper and a special material, spoiler alert, kitchen foil, don't hesitate to leave a comment below. We can conclude this theory overview by observing that in some cases it's useful to consider the equivalent series resistance of a capacitor, also called ESR, but this is an advanced topic that we can discuss in the future. Now let's see how to find a capacitor in a schematic and what are the symbols that represent it. Each of these indicates the type of a capacitor should be used. Some of them have a small plus on the side, and this is because some capacitors are polarized. That's why they must be inserted in an appropriate way to respect the current flow. As you can see, there are many symbols, and the most used are definitely the US one. More specifically, you may also see capacitor in a schematic with Japanese symbol, or this one very old and fancy. Always remember to check polarity according to the schematic. With electrolytics it's very easy, because the negative pole is clearly signed. For other types generally, there is a small plus on the positive pole. The unit to measure the capacitance is the farad, but practically we will always deal with its submultiples, such as microfarad, nanofarad or picofarad. Also, the values on the market follow the same standard as the resistor with the E series. With the electrolytic capacitor, I highly recommend to always check the maximum voltage that can support, otherwise, fireworks. Likely, the engineers have thought about this, and in the most recent one, we'll have a softer explosions thanks to the cuts in the after part that release the internal gas before detonation. If you want to easily identify the value of an electrolytic capacitor, it is very easy because it's written. As regards tantalum, ceramics or polyester, there is a specific code that identifies them. Unfortunately, there is no standard here, such as resistance, and the real value strongly depends on the manufacturer. For the ceramic ones, you can use this practical function in my app to immediately know the value reported by adopted standard. In addition, you can also get the code by value. If you want to know the real value, including more parameters such as ESR, it's possible buying specific tools like this LCR meter. Perfect, now we can finally go to the lab. This time, let's jump the main configuration. Indeed, we can connect 2 or more capacitors in series or in parallel, but I will explain how to calculate the total capacitance and other details in another video. Now, let's focus on how we can use capacitors. We can insert them in a circuit to filter any continuous components. So, for instance, if we have a sinusoidal continuous signal as an input, the capacitor is an excellent device for filtering the continuous component. In fact, they are also used as an input power filter to suppress noise, or also as a soft starter for a motor, or else to level an output voltage at the end of a full bridge rectifier, obtaining a stabilized direct current. However, they are often used together with a resistor in order to create a real-time circuits or as a low-pass or high-pass filters in simple audio applications. Lastly, in digital electronics, they can be used within memories for storing data. Great! So that's all for today. If you like this video, let me know letting up the like button, sharing and subscribing. If you have questions, please don't hesitate to comment. Don't forget to always expand your knowledge and see you in the next video.